mystery of the genetic material?
Holmes.
What is the genetic material?
Holmes.
What is the mystery of the genetic material?
Holmes.
What is the genetic material?
Holmes, I have the answer.
Speak up, sir.
DNA, sir.
DNA? And what is your evidence?
The evidence lies in 3 key experiments. The Griffith experiment, the Avery-McLeod-McCarthy experiment, and the Hershey-Chase experiment. Let me show you.
Well, hello there. Come on in. Don't mind these mice scurrying around. So as you know, I'm Dr. Frederick Griffith, and I work with 3 things: mice, deadly bacteria, and non-deadly bacteria. Today, I'm going to explain my experiment with the mice that has 4 trials. So, mouse number 1, he was injected with the non-deadly bacteria, and mouse number 1 actually lived. Mouse number 2, he was injected with the deadly bacteria, so mouse number 2 actually died. Mouse number 3, this mouse was injected with a heat-killed strain of the deadly bacteria. Now what this means is that the heat-kill strain has the deadly genetic material but doesn't actually have the means to replicate. Therefore, mouse number 3 lives. Mouse number 4 is where it gets interesting. Mouse number 4 was injected with a mix of 2 bacteria that were independently not harmful to the mice. Mouse number 4 was injected with the non-deadly bacteria as well as the heat-kill strain of the deadly bacteria. Mouse number 4's death actually shows that the genetic material must be transferable from the deadly bacteria to the non-deadly bacteria.
That happened to me too. I took art, I took art whenever, and then I took this
Oh my, I didn't see you there. I'm Oswald Avery. Sorry, my partners McCarthy and McLeod couldn't be here, but don't worry, I can explain our experiment to you. So in this special container, we have purified DNA from the deadly bacteria that Griffith studied in his experiment. Using saline solution, chloroform, and enzyme, we were able to purify heat-killed deadly bacteria, separating it from the active DNA. This active DNA was mixed with non-deadly bacteria and injected into mouse 1. Unfortunately, mouse 1 died. In a separate mixture, the polymerase enzyme was mixed with purified DNA, thus killing the transferability in the DNA. This was then injected into mouse 2, and mouse 2 lived. Thus, we're able to conclude that DNA is indeed the transferable material that was transferred between the bacteria.
Oh, yes, I've been expecting you. I'm Alfred Hershey. Unfortunately, my partner, Martha Chase, is unavailable since she's on vacation right now. Even so, I'm sure you all are eager to hear about our latest discoveries. As of lately, we've been using radioactivity to mark and track protein and DNA in viruses in order to procure evidence as to what the genetic material is used in viruses. So, in order to do that, we've been using radioactive phosphorus for viral DNA, as phosphorus is only found in DNA and not in protein. Likewise, we've been using radioactive sulfur for protein, as only sulfur is found in protein and not in DNA. After the viruses have injected their material into the bacteria, we found that only radioactive phosphorus is found in the bacteria. As a result, this implies that DNA is the transferable genetic material used by viruses.
So that is how we determined that DNA was a genetic material.
This is brilliant, Watson, but I must regret to inform you that there's nothing like first-hand evidence. We're going to have to do some experimenting for ourselves. Say, lend me a hair.
Will this suffice, sir?